Hi, and welcome to Conversations with B'nai B'rith. I'm CEO Dan Mariaschin. Today, we're delving into a rare genetic disorder that has significant implications for the Ashkenazi Jewish community, Transketolase, or TKT, deficiency. This condition, though newly identified, presents profound challenges for affected individuals and their families. Joining me today are two distinguished guests at the forefront of addressing this disorder. Harriet Schleifer is chair of the Conference of Presidents of Major American Jewish Organizations and the immediate past national president of the American Jewish Committee. She also serves as a trustee at Cornell University, vice chair of the Jewish Museum in New York, and sits on the board of the Washington Institute for Near East Policy, among other roles. In addition to her leadership in and beyond the Jewish community, Schleifer is a committed advocate for individuals with special needs, inspired by her own journey as the mother of a child diagnosed with TKT deficiency. Dr. Anna Szekely is assistant professor at Yale School of Medicine and an attending physician in the Yale Neurogenetics Clinic. Her research focuses on how less common genetic changes affect the brain, particularly through the study of rare genetic disorders like TKT deficiency. In our conversation today, we'll talk about what TKT deficiency is, how it's diagnosed and experienced, and how Yale's team is working to advance our understanding through clinical research and patient care. But before we get into today's conversation, a quick reminder: if you enjoy this program, subscribe to Conversations with B'nai B'rith wherever you get your podcasts and leave us a rating. You can also subscribe to our YouTube channel and follow us on Facebook to stay updated on all of our latest content. I'm looking forward to hearing more about how Transketolase TKT deficiency affects families and what's being done to make sure it's better understood and better treated. Harriet, Dr. Szekely, welcome to the program. Thank you both for being here.
And thank you for having us. Appreciate it.
Well, Dr. Szekely, for those hearing about this for the first time, what is Transketolase deficiency and what are some of the signs or symptoms that families or doctors might notice?
Yeah, thank you again for having us. TKT deficiency, as you mentioned, is a recently discovered genetic disorder. Is what we call is an inborn error of metabolism. So there is the TKT gene has a very important role in one of the specific metabolic pathway in the body, pentose phosphate pathway. And one of the key, what you are asking is the key of our quest as well. How easy to diagnose this disease? So there are several lifelong problems which may not be so specific and easy to recognize, like children have overall neurodevelopmental delay, short stature, heart defect. This is not uncommon, but then there are unique features of this disease which have been recently discovered, and that includes early joint inflammation, inflammation of the eye, cloudy lenses like cataract, very specific gastrointestinal problem like dealing with releasing digestive enzymes, difficulty with the pancreas function. So one of the thinking what we have, and I had a great pleasure, of course, to meet Harriet and her son, David, who is affected, is that there are enough unique, significant clinical findings which a clinician with good eyes can recognize. This disease has been discovered as an effort of large-scale effort in Colombia to study children with intellectual disability, and that to date about 9 patients have been described. But our thinking with Harriet, and we had a lot of discussion, that, and we know that the prevalence of disease is much higher and is really underappreciated, and partly because of those less specific symptoms, what we are talking about.
Harriet, there's a truly human, deeply personal aspect to this. As a parent, what first led you to seek a diagnosis? Because from what we've just heard, there are multiple symptoms. And I'm assuming that not everyone has all of the symptoms, but
That's right.
everyone has some of the symptoms. What were the signs or challenges that made you realize that something more was going on?
David was almost full term, but had a low birth weight for, the pregnancy. And interestingly, when I think back, I never felt him kick. I only say that because as he, was an infant and then a toddler, he had low muscle tone. Nobody knew what was going on. At 8 months of age, he was wearing glasses. He had esotropia. And then later on developed cataracts in his adolescence and had the surgery, and then developed uveitis and inflammation of the eye. But he also was cognitively or intellectually, he didn't hit his milestones. At this point, he's 38 years old. And, I look at him as an 8-year-old child from his cognition in terms of, capacity for higher functioning, even though there are strengths, great strengths, non-verbally, but verbally, he's very much a younger person. He also had significant behavioral issues, and his language is quite delayed. He presents as a much younger person after your initial meeting with him, because he does have features of a mature person, such as a beard that grows, etc., and some gray hair. But once he starts to speak, it's extremely evident that we're dealing with a younger person. And, as a child, he was treated for failure to thrive. We had all the genetic testing that was known 38 years ago. Of course, this specific mutation was unknown until more recently. And David was only diagnosed with this when he was 33 years old. Oh. So we went about our way first with, I'm a spiritual person, and I felt that, because of my nature and my husband's nature, there was a greater plan for us to have a child, raise this child, and do the best we can, for his quality of life. But then 5 years ago, the science came crashing down, and it was a confluence of faith and science that jolted us to decide that if not us, then who? If we don't do something about this and learn more about this, who will? It's like Hillel.
Exactly. Dr. Szekely, when exactly was TKT deficiency first recognized as a distinct disorder? Because there are other Jewish genetic diseases, okay. Some connected to Ashkenazi Jews. And, we live in an era of tremendous medical advances, research advances. Why do you think it took so long to gather the information and then come up with this designation?
It's an excellent question. I think partly the research in clinical genetics has changed. So this syndrome has been described by Dr. Wendy Chang at the time in Columbia. And they have used a unique high-throughput sequencing approach looking at a large number of children with various developmental delays. And we are talking about thousands. And meanwhile, they were able to identify the clinical features. And that was a time when they have recognized a certain type of mutation of TKT, which is very unique to the Ashkenazi population. This is the one. It's well known probably for the audience's founder mutation, which is present. And there were significant similarity clinically between the children. So they were able to describe this syndrome. Nevertheless, it's a great effort, obviously, and there are many, many similar efforts. But people are not as much aware of this variability. There is a huge number of diseases which discovered. So we had a chance to diagnose David at Yale, the time using a large-scale sequencing effort called whole exome sequencing. It's an unbiased looking all genes along with his clinical difficulties. So that's, and recognizing the literature that this has been described. So it's partly an approach, partly the modernity of sequencing efforts, looking large-scale studies and being very, very observant on clinical details.
Can you explain this? We're going to go back a little bit. Explain in simple terms what the TKT gene does and what happens when it doesn't function properly.
This is yet again a great question, because this is one of our great interests. I don't think so people know exactly how you end up with this complex disease. We know that this gene has some metabolic function, ultimately related to energy utilization, but that alone may not explain exactly all the unique features what we discussed. The enzyme, this is an enzyme, which one feature is that, again, this glucose and carbohydrate metabolism pathway, the enzyme activity is close to zero with the mutation. So there are probably other genes which somewhat trying to compensate as happen. Otherwise, it would be difficult to be compatible with life. But the other question, what we are particularly interested in, is a rather recent discovery that this gene, for an unknown mechanism, is very uniquely involved in immune regulation, particularly as type of cell T cells. And that is something which is an absolutely fascinating and unexplored avenue, particularly thinking about relationship between immune system, inflammation, and metabolism, and also knowing that the patients who are affected with this deficiency, they do have early inflammation, as Harriet was just explaining. So it's not much known, and this is one of the great impetus for us to explore this rather myriad effects which likely this enzyme has.
Harriet, thank you. Harriet, you've talked about about David and the symptoms. Has this advance? How has it changed things for your family? I mean, has it brought more clarity? Clearly, it's brought your not only your interest but your active advocacy for telling the story and for getting the story out. So how has it changed things for you?
It's given me something to work on. It's given me like hatikva, because my journey will be with the Yale team to identify people who are out there who may be undiagnosed, have the same issues I've been dealing with. I mean, it even goes, to be very blunt, it goes to stool production and social consequences of, your regulatory digestive function. Now, knowing this, my son takes an enzyme before he eats anything to help him absorb the nutrients and allay some of the undesirable effects of not having a good digestive mechanism. So it has social, the cognitive delays have social ramifications. It's isolating. Now I feel like with a cohort that I can be looking for and the few individuals we already know of, we have a basis to talk with each other, support each other. But now it has to be forward-looking. Now it's not enough for me to know that this is what's happening. I have to find out who else is out there, what their symptoms are, what their quality of life is. what the longevity, what the comorbidities could be as someone ages. Then we have our clinical research that's being done at Yale regarding inflammation. And I can tell you that my son has, all the clinical indicia of a systemic inflammation, and he is always complaining about pain. He has constant pain, and we keep trying to figure out what's causing the pain. He says he doesn't sleep well because, he has this pain or that pain. It's very disconcerting to a parent to listen to a family member and a child. Well, he's a young man, but your child who says he's in pain because you don't want to feel helpless, and yet right now you do. And then the other prong, so we have like identification of existing people. We have the clinical research on inflammation that I hope, will yield, further treatment and benefit. And then we would like to get this on the screening panel. TKT is not yet on the screening panel, and Dr. Szekely will be able to tell you that it is technically not a big deal to add this to the panel. And for example, when we found out that David had this mutation, we had my older son tested. He was about to start a family. It turns out he's a carrier. This means I'm a carrier. My husband is a carrier. My older son is a carrier. And then we had to test his wife. She is not. Therefore, he cannot produce children that look like his brother, but he could be able to pass on the mutation to his offspring. So how many of us carriers, can then have children who are carriers who can then beget the children who are impacted with this? And then the fourth thing would be, God willing, to have animal studies isolate the gene and be able to insert the gene so, we can avoid a child who inherits both copies, therefore leading to this syndrome. So we have four major goals.
Dr. Szekely, that leads into the broader question right out of what Harriet has just explained.
Yeah.
It's been noted that this condition primarily affects individuals of Ashkenazi Jewish heritage. Does that mean, following what Harriet has just explained, does that mean that both parents need to carry the mutation for a child to be affected?
Right. So this is a classical autosomal recessive disease, like many of those diseases in Jewish panel, like Bloom syndrome, Tay-Sachs, all that. So both parents are carriers without any symptoms. And then there is a 25% chance that each of the future child would inherit the mutated gene copy and then develop the disease. The reason I brought up Bloom syndrome, and we feel very passionate about that the frequency of this being a carrier is very much in line with a huge number of diseases in the so-called Ashkenazi Jewish panel. So we talk about the famous founder mutation, which is very typical, is very straightforward to identify. The range of the carrier can be 1 to 160 or 1 to 250. This is well in range of a large number of diseases. The Bloom syndrome, which I worked before on in my younger years, this is part of the routine screen and has a much less frequent carrier frequency. So we are very committed that making awareness of this disease, having carrier frequency established, having the possibility of screening for the Ashkenazi Jewish mutation. There are a few additional mutations on these genes, but in non-Ashkenazim with a much less frequency. But this is something which is a very high number considering. And it, as always, asymptomatic. You wouldn't know that you carry this.
So it's likely that many individuals remain undiagnosed.
Exactly. So for multiple reasons, partly is the unawareness, partly because some of the symptoms are not so striking. Some are unique, as we discussed, but also there is a high carrier frequency.
And it was only discovered. I mean, the
That's
point
right.
is that the science is now enabling us.
Right. Harriet, I'm curious, how did you first connect with the team at Yale, and what made you want to get involved more deeply in the research? You cited Hillel's famous saying, but it's clearly more than that. So tell us how you got connected to Yale and what drives you to be the principal advocate for knowledge about this, about TKT.
My son David has lived in the New Haven community for the last 19 years in a special school class community called Chapel Haven Schleifer Center. And his doctors have moved in these years from New York to New Haven, Connecticut, and of course, Yale. It's a gem. It's in fact, we're very lucky to have Yale be our center of clinical treatment for everything. So Dr. Szekely is the person that actually had the idea, together with Dr. David Hafler, to even run a genetic sequence. He was at the neurologist's office because he is prone to migraines. He's had complicated migraines as a child that left him looking like he had a stroke several times. And as he got older, he still complained of migraines without the paralysis that he was experiencing. And at the neurologist's visit, Dr. Hafler and Dr. Szekely, and my husband was the one who was there at that visit. So Dr. Szekely, you can fill me in as well about your offer.
It was a very, very efficient and productive visit, needless to say. And we have been committed to use the latest state-of-the-art sequencing technology, looking truly very carefully, basically the entire gene collection. And that was offered immediately to David.
Why? When you looked at him?
I mean, as a clinician, you do see that there are difficulties, and exactly because of dilemma that what is specific and what is less unique, you want to be as carefully and widely thinking. And this kind of large-scale sequencing for diagnosis, which we have been using, and I'm using that quite frequently, that is the way to diagnose which you can analyze 20,000 genes and understanding exactly. It was not a dilemma when we found the mutation, so it was not a question at that time, but it was evident that he has a genetic condition based on clinical judgment.
So I want to know.
Go ahead.
I just have to say, when he was 18 months, a year to 18 months, he was presented at grand rounds at Cornell twice. And the feedback we got from the physicians at the grand rounds that he looked impish. And the geneticist in those days at Cornell, having been unsuccessful in finding diagnostic information about this, had a photo album. They used to have a photo album of children who looked a little different or presented differently. And we would sit and go over pictures of other children to see if David looked like or resembled any of those. Now, look at that 38 years ago, and I'm looking through a picture album. Fast forward to today.
Dr. Szekely, has Yale's outreach helped uncover more cases or helped other families seek care? And is the Yale School of Medicine, or more specifically, the Yale Transketolase Deficiency program, working with other institutions in this space as more becomes known?
Right. So, with the generous philanthropy of the Schleifer Family Foundation, Yale full-heartedly established this program with multiple missions. So one of them is obviously exploring and identifying patients who are diagnosed or who may be having signs of the disease, and we would help to diagnose. And in that end, we would obviously, we are starting to interact with other, making available for the public, for clinicians, for communities at high risk, particularly, and that's why we're grateful for the opportunity to talk to you as well, the Ashkenazi Jewish community, being available for referral. So this is a one major approach. We established a team to provide a multidisciplinary care. So we would like to be the experts in that sense. Is standard care, but we would understand these patients much better. So we would serve as an open referral and advise as well, helping diagnosing. So this is one part, but the other is the research part, which I'm a little bit in terms of characterizing the very fine clinical details and more the genetic background in anticipation of animal models and so on. And there is this large basic science interest of Dr. Wang, Andrew Wang, and Dr. David Hoffler, a world-renowned immunologist, who have a wonderful project to analyze very well exactly the molecular nature of the TKT deficiency in terms of other interactions. So there are nationwide organization, the Undiagnosed Disease Network, and the National Organization of Rare Disease. Yale has been a center of excellence for both of these nationwide organizations. We are interacting with them and trying to identify patients, and we do everything in our capability to make this disease well known for the communities, pushing the screening, offering ourselves for help in any way we can.
I think it's like an education push as well. We're going to have to go out into the communities of synagogues and genetic screening organizations to push out the education and awareness.
Have you had the chance, Harriet, to meet other families going through something similar? And what kind of support, formal or informal, do you think makes the biggest difference?
Well, I'm in the early stages of gathering our volunteer parents who the other children that were earlier discovered to have this disease. I'm in contact with them. We've had Zoom calls. We're trying to split up the effort. So I'm the one that has more contacts in the Jewish communal world. So I'm taking it upon myself to do the outreach to the Jewish communal world, but I'm having my other parent family members reaching out in their communities, and we will have regular meetings to see the progress we're making in terms of education and helping find other individuals who would be open to be screened. So we're trying to divide the work.
Harriet, from your perspective as both a parent and an advocate, if you had one message to give today, what would you like to share with other families who might be navigating the challenges of a rare genetic disorder like the TKT deficiency?
I would say you're allowed to cry. You're allowed to be upset, and then you have to pick yourself up, learn as much as you can, and seek out other partners and forge ahead with a resolution, and just to be active advocates for yourself. And the rest will fall into place, we hope, with the help of a higher order.
With a closing question to both, I'd like to hear from you about this. What gives you hope right now, whether it's a breakthrough in the lab, new connections with families, or momentum in awareness, which we just talked about? What's encouraging you as this work moves forward? Each of you. Dr. Szekely.
Well, just continuing Harriet's thought, in my genetics clinic, I have a chance to meet wonderful families whose entire life has changed, but they are highly committed. So one of the hope is that all of those families who have concerns with their children and they may not have such a support from their local communities, or they say, don't worry, it will be better, or no hope, that they continue to seek out help and looking for trained geneticists and taking advantage of the new technology and reaching diagnosis, particularly if there is a risk and particularly if we can implement more screening. Hard to choose which one is the hope. I think that on a clinical end, this is the hope that this making one of the standard classical Jewish disease, not happy with it, but having screening that makes absolutely possible that one can prevent to have more significantly affected children is a major heartache for everyone, for the children, for the patient. Particularly, the research, I am very optimistic. The approaches what we are using here at Yale is just highly state-of-the-art. There is a tremendous new direction of thinking about normal inflammation and metabolism and how they are interfering. So this is a totally new direction from a clinical end and would give a very new opening for using a rare genetic disorder. This approach, using a rare genetic disorder, understanding way larger problems and common problems, is not new. I mean, if you think about Alzheimer's disease back then, it was used by exploiting rare familial cases. So this is an extraordinary opportunity to fall together, I guess, utilizing this disease.
Harriet, the final word.
So what gives me hope is the quality of the care that David has received and the real interest and dedication of the medical professionals at Yale that is working on this. Dr. Szekely, Dr. Andrew Wang, Dr. David Hafler. You can't buy the kind of dedication, interest, and intellectual heft that these people have. So I consider myself extraordinarily fortunate to have intersected with these wonderful doctors.
Well, Transketolase deficiency may be rare, but as we've learned, its impact is profound, touching lives, challenging families, and inspiring cutting-edge research. For more information on TKT deficiency and the research being conducted, please visit the Yale Transketolase Deficiency Program page at medicine.yale.edu. Harriet, Dr. Szekely, thank you both for shedding light on this important topic. It's been a real pleasure speaking with you, and we wish you continued success in your advocacy and your research.
And great thanks to you, Dan, and B'nai B'rith for giving us the opportunity to speak with you.
Yeah, thank you so much again. This is a great opportunity.
Well, that's it for today's episode of Conversations with B'nai B'rith. Thank you to Harriet Schleifer and Dr. Anna Szekely for helping bring greater awareness to transketolase deficiency and to the focused efforts at Yale School of Medicine to better understand and address it. Remember, the conversation doesn't end here. Share this episode with others, post about it on social media, or leave us a comment or a rating.
You bet.
To stay updated, follow or subscribe to Conversations with B'nai B'rith wherever you get your podcasts. And be sure to subscribe to our YouTube channel and like us on Facebook for more great content. We'll be back soon with more thoughtful conversations on Jewish family, history, culture, and the issues that matter most to our community. Until then, for my guests, I'm Dan Mariaschin. Thanks for watching, and take care.